Hi, this is Mr. Wu, and welcome again to Disney Park Math. In episode 5, I'll talk again about acceleration and g-force featuring the ride Rock and Roller Coaster. Now, if you haven't viewed the previous episodes, especially the first two, I definitely recommend going and doing that first to make what we talk about here make a little more sense. So Rock and Roller Coaster. Now this ride comes from Disney's Hollywood Studios in Orlando. It's part of the Walt Disney World Resort. It's one of my favorite thrill rides for a few reasons. First of all, it combines modern features of roller coasters like magnetic launches and a nice smooth steel track, inversions, and add to that it's an indoor roller coaster, similar to the idea of a ride like Space Mountain. Maybe not quite as dark, but definitely compact, very thrilling. Added to that is also a great story. In this particular ride, you enter a music recording studio where you meet the band Aerosmith, and then he and his band invite you off to a concert. So you get in a limousine and you're racing on the freeway to get there in time. So really quite a great combination of all those things. So let's see what this ride looks like. In this particular video, I show you pretty much the ride launch. I felt it was maybe a little too intense for me to record the whole thing. Maybe one of these days I will. Okay, so again, go ahead and fasten your harness and let's see what this looks like. There's the limousine and the launch portion. And here we go. Okay, just a sneak peek there. The actual ride, of course, is longer. That initial launch is pretty intense. It goes right into a looper inversion right there. So some pretty cool G-forces there. Alright, so let's do some problem solving with this ride. So the Rock and Roller Coaster accelerates from 0 to 60 miles per hour in 2.8 seconds. At this rate, how long in seconds would a launch from 0 to 100 miles per hour take? And about how many G's is produced in the direction of the launch? Now, if you need to, you can go back and review my episodes in California Screamin', which involve similar problems, to see what you might have done there. Okay, why don't you go ahead and pause the video and try and work these out and see what you get. Alright, did you work out a possible solution? Let's see what this might look like. There's two parts to this problem. Here's the first. Now I'm going to use a proportion as a tool again here. So using our acceleration as a ratio, 60 miles per hour in 2.8 seconds. If we were to redesign the ride to accelerate to 100 miles per hour, how long would that take? So x is our unknown. Now using cross products to solve, 60 times x is equal to 2.8 times 100. So 60x is equal to 280. Now dividing both sides by 60, I get x is equal to 4.67 seconds. So that's how long it would take to get to 100 miles per hour. Second part of the problem. So using our acceleration again as a ratio, so 60 miles per hour in 2.8 seconds. But first I'm going to turn this into a unit rate to make this a little more easy to deal with as a single number. So 60 divided by 2.8, I get 21.4 miles per hour per second. Now using a proportion again, remember 1 g of force is produced by the acceleration due to gravity, which is 22 miles per hour per second. How many g's of force would be produced by our acceleration of 21.4 miles per hour per second? Now we can reason to be pretty close because these numbers are so close. In fact, we could estimate it's a little bit less than 1 g. But we're going to find out with a little more certainty. So using cross products, 22 times x is equal to 1 times 21.4. So 22x is equal to 21.4. Dividing both sides by 22, I get x is equal to 0.97 g. So our estimate would be about correct, a little less than 1 g of force. So, in conclusion, a launch from 0 to 100 miles per hour would take about 4.67 seconds, and a launch produces about 0.97 g. Now again, that might not seem like a lot, only about 1 g, but remember, this force is coming from behind us in our backs. We don't normally feel that kind of force there, so it makes it thrilling. And that launch is definitely thrilling. If you also remember from the video something about experiencing a force of about 4.5 g. Now where is that coming from and why is it so high, or higher than 1 g? Now if you remember, it's the changes in velocity that produce the acceleration that produces g-forces. And those changes can come from a couple of different things. First of all, it can be the magnitude. So going from 0 to 60 miles per hour, that produces a force that we feel, that 1 g of force. But it's also the direction. If you remember, the launch goes straight into an inversion or loop. So the track changes direction quite dramatically. So not only going fast, now the direction is changing, and that's going to add even more force to the ride. In fact, quite a bit. So it really adds to the thrill of that ride. So hope you get to check it out sometime if you haven't.